Hi friends, we are going to start with new and very interesting topic of climatology. That is the study of climate. Now I said interesting because as compared to the earlier topic what we have done, it is a very interesting topic. We have studied the geomorphology early, but this climatology is a dynamic topic, it is an interesting topic and more interesting because we can understand this concept and relate it to our everyday life. So this study of a climate, the study of atmosphere and what are the changes in this atmosphere composes of the climatology. To give a brief idea how will our lecture series progress, we'll start from the structure of atmosphere. We'll then go to insolation and heat budget. Then we'll do a small topic of temperature, pressure, resulting from the pressure system winds, humidity in the or moisture in the atmosphere, resulting into precipitation, this all clouds, air masses and fronts, and some of the atmospheric implications of this in the terms of cyclones, in the terms of anticyclones, and other weather phenomena. So we are going to study these different topics this is just a broad outline of how our climatology will go, and it will be much faster as compared to the earlier part, that is the geomorphology part, and also I promise you that it will be very interesting as compared to the geomorphology part. Now the best thing of climatology is, even in the examinations, climatology forms a more important part as compared to the geomorphology, especially in the preliminary examination and even in the some mains examination. Plus you are more expected to get an essay on climatology if the essay is something on geography, or we are expected to get an essay on the urban part of geography, that is the human geography part. But if the essay comes on the physical part of geography, obviously it will be on the climate change. We will study here some of the important facts related to the environment. Here some of the important facts related to the pollution part. So these are the important facts in which we will study the climatology. The study of a climatology in detail will also help you in understanding the environment and ecology portion. Why at that? Or we can correlate the environment and ecology biomes part with the climatology part. So this climatology is very important, and as we are all subjected to geographical condition, here the climatology plays a very important role, because the geography, physical geography determines our human geography or economic geography. It is not as if that we will cover ourselves with 3 or 4 different layer of clothes if we are staying in the equatorial region, or if you are staying in the hot region, or it is not exactly vice versa. We won't cover ourselves with very fine single layer of cloth in cold polar regions. What is our economic criteria will also depend on the weather and climate of the region. Why I am saying economic criteria? Because you do not expect rice to grow in the Rajasthan region. Similarly, we do not expect wheat to grow in the Konkan or West Bengal region, or in the Sundarbans region. This all have some of the specific facts determined by the climate. We won't expect tea and coffee to grow in the top layers of the Himalayas. Tea and coffee require some kind of a climate, hot, humid climate. So it will grow in some specific regions only. So thus the climatology will impact our economic life. It will impact our mostly agriculture life. It will impact the soils in the region, and overall it will impact the industrial processing regions. So this climatology First, we'll start from the simple topic, that is the study of the atmosphere and what are the different kind of structures of the atmosphere. Then we'll go to insolation and heat budget part, temperature, pressure, winds, moisture, the examples of a moisture, cloud, air masses, fronts, cyclones, anticyclones. If we try to look at it scientifically, climatology is nothing but outcome of three important factors. If we take world as a system, what is a system? What is the definition of a system, both for science as well as humanities background students? System is anything in which we put input, we get a specific kind of an output. So if we consider Earth as a system and we give three inputs to this system in the terms of heat or insolation, in the terms of humidity, and in the terms of pressure, if these are the three inputs inside the Earth, then we'll get the output in the terms of temperature or heat, which will drive the moisture content or humidity, or we can say precipitation or rainfall, and which will drive the wind system. So climatology is studying each and every input and output relationship is nothing but the climatology. Very, very simple. That is, if we put in these three factors, we get these three factors as an output. The study of these factors is the climatology. If we consider Earth as a system, and if we input these three, we give these three inputs to the Earth, we will get the following outputs from the Earth. Insolation, temperature, and insolation, humidity, pressure will affect the temperature, precipitation, and winds. And these are not isolated; these are related to each other. That is why I have taken a single arrows to determine all the three. They are all interrelated, all connected. But before that, why there is life on the Earth? Is there something related to climatology, or is it something related to oceanography, or is it something related to geomorphology, or is it something related to all three? The life on the Earth is sustained. Obviously all three will be little bit related, but the most you can say closer relationship is due to the climatology. That is, there is a presence of atmosphere, there is a presence of gases, there is a presence of some kind of an covering on the Earth which supports life system on the Earth, which supports oxygen which is required for support of life system on the Earth. There are some kind of you can say atmospheric gases or conditions which support the presence of liquid water on the Earth. And the presence of liquid water is one of the most important necessity for sustaining life on the Earth. In fact, what we are doing, we are sending Kepler telescope, we are sending the Kepler in the outer zones and finding why is there any kind of a presence of water in the form of liquid on the outer space. If we find the presence of liquid in the outer space, that means life form will be possible. So the area where such life form will be possible, where the atmospheric conditions are similar to that of the Earth. So obviously Earth is at some kind of a specific distance away from the Sun. Similarly, there can be other planets in the solar system which will be at a similar distance from the Sun, from the respective Sun, from the respective star. Such a zone where there can be a different planet is known as a Goldilocks zone. So what is Goldilocks zone? Why Goldilocks zone is becoming important? Because of the presence of why there is a life on the Earth, atmospheric conditions. Similar atmospheric conditions, maybe life will be present somewhere. Mayan civilization. one of the oldest civilization. If you want to see, you just search on the YouTube or search on the net and see the sculptures of the Mayan civilization. We will see, you will be surprised to see that the Mayan civilization have sculptures which show Mayan civilization was in before Christ, some 100 or 1000 years exactly, I don't remember the date, 1000 years before Christ, Mayan civilization. But the sculptures of this one of the oldest civilization show the astronauts and sculptures show as if the extraterrestrial life was possible. Structures show the presence of a rocket system there. The sculptures show that the suit which is used by an astronaut is somewhere reflected in the structure. So that means there may be some kind of an extraterrestrial life. This is not our, you can say, we are not concerned with this because this is now out of the syllabus. So I will come to it later on where we will be discussing solar system, that is at the end last part of our lecture series. But where is it possible, and that is why we are going in the outer space. Kepler telescope has been sent to find such planets which are located in a Goldilocks zone. But before that, we will start with some of the basic part of climatology, that is atmosphere. Why Goldilocks zone? Because such kind of an atmospheric conditions should be present. So what is this atmosphere? If there is such kind of an atmospheric conditions, then only the life will be possible. So what is an atmosphere? We have finished with the structure of the earth. Presence of land on the surface of the earth, that is this part. And because this is geography, we have gone not too much deep inside the interior of the earth. We have just did some part of the interior of the earth. But so the land is surrounded what we call as a geomorphology or and then there is this part which is known as an oceanography part, that is the presence of water here. We have not done this topic, oceanography. Now the third part is there is an envelope, gaseous envelope, or we can say there is a gaseous covering on the surface of the earth. This gaseous covering which covers the entire surface of the earth, this covering of a gas which covers is known as an atmosphere. So what is an atmosphere? Atmosphere is a gaseous covering which surrounds the earth or which covers the earth. It is like a protective layer around the earth. And this gaseous covering which covers the earth covers the earth and supports numerous life forms on the earth, supports climate on the earth which makes this life forms possible, supports different kind of seasons on the earth, is known as an atmosphere. So what is an atmosphere? First, because it is a climatology lecture, the basic definition, what is an atmosphere? So what is atmosphere? It is a atmosphere, we can write the definition as a thick gaseous envelope which surrounds the earth from all sides. Is known as an atmosphere. Now why it is just surrounding the earth, or why the atmosphere is, that is what is an atmosphere? If this is an earth, a gaseous covering, a gaseous envelope which surrounds the earth is known as an atmosphere. Why there is a gaseous envelope like this? Because it is attached to the surface of the earth by the force of gravity. So this is half incomplete definition. The thick gaseous cover envelope which surrounds the earth from all sides and which is attached to the surface of the earth. Which is attached to the surface of the earth. By gravitational force. By gravitational force is known as an atmosphere. Is known as an atmosphere. So this is the definition of atmosphere, and the study of the atmosphere and the, as I said, various inputs in the atmosphere and the relating outputs is known as climatology. And in last part we will study the effects of nowadays very important question from an important component. Even if you are a world citizen, Indian citizen, world citizen, and responsible, or you can say thinking person, or you are a student of UPSC, climate change is an effect, is one of the most important topic which you should know. So that will come at the end part. First, the study of an atmosphere. A thick gaseous envelope which surrounds the earth from all sides and which is attached to the surface of the earth by the gravitational force is known as an atmosphere. Now what is the importance of this atmosphere? What is the importance of the atmosphere? If the question comes, what is the importance of the atmosphere, or why is the atmosphere important, then I am speaking to you, you are watching these lectures, it is because there is some kind of a support of a life form. So, and this life form is supported because there is a presence of such a mixture of gases which makes the life form possible. For example, there is a presence of nitrogen, there is a presence of oxygen, there is a presence of carbon dioxide in such a proportion in which, because of which the life form becomes possible, and that is why we are here on the surface of the earth, and we are searching for other planets where also same atmosphere may be possible. But what is the first thing, what is the first important atmosphere, importance of the atmosphere? It supports the life form on the earth. What we call as an biosphere, or we call it as a biospheric ecosystem. Why biospheric ecosystem? Because we do not live in isolation. We for people who are living on this, you are watching the lecture, I am giving here the lecture, I am interacting with you. So the interaction between the human beings. If I go down, if I go out from the lecture hall, if I walk on the roads, I will be interacting not only with different kind of human beings, but being a country, I also maybe interact with a cow which crosses my road. So a life form which is not of a human species. That is why we are a living community which is interacting, but not just that interaction. I also have to live with, for living I also have to intake and gas, oxygen. If there is too much pollution on the earth, it affects me. So the interaction by the community, that is between different organisms of maybe same species or of different species, and the surroundings, that is the surrounding environment, that is the abiotic life form, that is nitrogen gas, oxygen gas which we are taking. These are not living things. Oxygen is a gas, it does not have life in it. So the interaction between the living and non-living is an ecosystem, and the biospheric ecosystem is in the atmosphere. If this is the earth, and if it is surrounded by an atmosphere, we are not concerned with this entire atmosphere. We will be concerned only with the top, this layer. That is, if this is the entire atmosphere, we will be concerned with only this part where the life form will be possible. Why the life form is possible? Because the conditions are such that the interaction of human beings, interaction of living beings along with the non-living beings makes this life form possible. So this is known as an biospheric ecosystem. So what is the importance? One of the first importance of an atmosphere is it provides the necessary gases which supports the life on the surface of the earth. Provides all necessary gases for life, or we can say sustenance of life on the surface of the earth. For sustenance of life on the surface of the earth. So had there been no atmosphere on the surface of the earth, what would have happened? Had there been no atmosphere on the surface of the earth, life would not have been possible. So our surface of the earth would have been barren like the surface of the moon. What is the difference? The moon is a satellite of the earth, but there is no life on the moon. Why? Because there is no atmosphere on the moon. In the absence of atmosphere, life on the earth would not have been possible. Would not have been possible. That means biospheric ecosystem would not have been possible. So this is the first importance of the earth, so of the atmosphere. The second importance of the atmosphere, I am rubbing this definition. The second importance is we generally, if you are living in the tropical part of India or maybe any part of India, nowadays, especially nowadays, there is too much of a bombardment from the advertising industry, UV creams or the shield sun protection screens, sunscreens, etc. Or why we apply these creams on our body? It's to protect ourselves from UV rays. We use glasses, anti-reflecting glasses, to protect ourselves from UV rays. So why this UV rays? Because the sunlight also contains infrared and UV rays. It is the presence of ozone layer in the topmost layer of the atmosphere which protects the, or which absorbs the UV rays and does not allow large amount of ultraviolet rays from reaching the earth. So obviously this ozone is in part of atmospheric gases and it is in part of atmosphere. So second importance of atmosphere is it does not allow harmful ultraviolet rays. It does not allow harmful ultraviolet rays to reach the Earth's surface. To reach the Earth's surface and thus protects the Earth's surface and thus protects the Earth's surface. So the importance of the atmosphere is it provides all necessary gases for sustenance of life, what we call as an biospheric ecosystem or biosphere, and it does not allow the harmful ultraviolet rays from reaching the earth's surface. Why it does not allow? Because there is a layer in the structure of the atmosphere which is known as an stratosphere, which has a concentration of ultraviolet rays, and it takes up this ultraviolet rays, it absorbs this ultraviolet rays. Now this absorption of this ultraviolet rays, it does not allow this absorption of this ultraviolet rays results into ultraviolet rays not reaching the surface of the earth, and this ultraviolet rays, because they do not reach the surface of the earth, life form is possible. How? Why? Now, are we responsible, we human beings, due to our, we can say, consumerism, or we can say any kind of we have depleted the environment, we have depleted the atmosphere by releasing harmful gases. We have also depleted the ozone layer, and as a result now there is an ozone hole, and hence large amount of ultraviolet rays do reach the earth's surface, resulting into cancer and other diseases in human beings. We will come to that later on, that how we have stopped it, which protocol is there, etc., while doing the structure of the atmosphere. So this atmosphere, the importance of the atmosphere. Now, what is the height of an atmosphere? What is the height of an atmosphere? You look up in the sky, you will see the sky. What is the exact height of the atmosphere? Is there any different layer? Or when we look at the horizons, do we see colorful bands representing different height of the atmosphere? No. The height of the atmosphere is actually, we don't know the exact height of the atmosphere. We think that height of an atmosphere is approximately around 16,000 or around 29,000 kilometers from the surface of the earth. So there is the height of the atmosphere is very vast, but we are not concerned. Can you go up in the sky and live at the height of 16,000 kilometers or 29,000 kilometers or even 1,000 kilometers? Can you go and settle on Mount Everest? No. It is very difficult. Siachen Glacier, the government of India spends so much, large amount of budget is spent to support the soldiers which are present on the highest battlefield in the world, that is the Siachen Glacier. Google or see in your atlas, what is the height of a Siachen Glacier? Is it 1,000 kilometers away, or it is 1 kilometer away, or it is 10 kilometers away from the surface of the earth? We cannot. It is only the lower part of the earth which supports the life form. So, if the height of the atmosphere an atmosphere is between 16 to 29,000 kilometers. To 29,000 kilometers from the surface of the earth. From the earth's surface, but as I said, we are concerned with only the major part of the atmosphere. As you are going away from the atmosphere, see what happens if you go to Leh Ladakh region, what happens if you go to the mountainous region. Is there too much of oxygen in the atmosphere, or is there a decrease in the oxygen? As we are going up, as we are going away from the surface of the earth, do we get more oxygen, or do we get less oxygen? Mountaineers, climbers, people who climb the highest mountain, do they carry oxygen cylinders along with them, or do they practice high breathing? Or recent in the news, Amarnath Yatra, is everyone allowed for Amarnath Yatra, or is there a medical checkup? There is a medical checkup, and if there is a heart disease, heart condition, the permit is not given. Why? because Amarnath lies at some kind of an height. As you are going away from the surface of the earth, if this is the surface of the earth, height of an atmosphere is around 16,000 kilometers, no doubt about it. But if you are going away from the height, from the surface of the earth, the density of the air goes on decreasing. The air is becoming less and less dense. It is becoming rare or rarefied. And as a result, when we go on the top of a mountain, there is less oxygen and we experience breathing difficulties when we go on the top of a mountain. So, though the height of the atmosphere is between 16,000 to 29,000 kilometers, we are not concerned with this height. We are concerned where the life form is possible, up to the lower part, up to lower 29 kilometers, where the life is possible, and 97% of the atmosphere is concentrated in this lower 29 kilometers. Why I am saying 97% atmosphere? Because यहाँ पे atmospheric density is very high, बहुत ज़्यादा dense है, and इसलिए life form is possible. इसके बाद though height is more, it is becoming rare. It is becoming less and less dense. So the height will be there, but becoming less dense. What is the practical implication in the mountainous regions? As we go up, we are going in the area where there is less and less dense air, and we experience breathing difficulties. So the effective height of the atmosphere, but 97% of the atmosphere, but the 97% of the atmosphere is confined to height of 29 kilometers, and 50% of the atmosphere, and the 50% of the atmosphere lies below height of 5.6 kilometers from the surface of the earth. So these are the important facts you should know. What is the height of the atmosphere? 16,000 to the 29,000. There is a very high upper limit, but most of the atmosphere lies below 30 kilometers. In fact, below 29 kilometers. How much? 97%. And 50% of this atmosphere lies even below 5.6 kilometers. So we are going to study about this 50%. That is, here all the process in the atmosphere takes place. What are the processes? As I told you, rainfall, precipitation, insolation, cloud formation, cyclone formation, etc. We are concerned with this. So because why 50% of the atmosphere lies below the height of 5.6 kilometers. So this is the height of the atmosphere. Now what is the atmosphere composed of? If you go out and take an open air, what will be the composition of the atmosphere? Composition means what is the atmosphere made up of? We know that the atmosphere is made up of gases. Because we sweat, we know that the atmosphere is made up of water vapor, and because there is dust particles, and when the sunlight enters the dark room, you can see large amount of dust particles being suspended in the air. We know that the atmosphere is made up of particulate matters or small tiny dust particles. So what is the composition of atmosphere? Atmosphere is made up of gases, water vapor, and lastly particulate matters or small tiny particles matter or particulate matter. This is the composition of the atmosphere: gases, water vapor and particulate matter. Now because we are concerned with only lower part of the atmosphere, we are studying the composition of the lower atmosphere. Lower atmosphere is made up of gases. What are the different kind of gases present? Oxygen is there, nitrogen is there, carbon dioxide is there in different proportions. Water vapor is also present. Now if you are living in Chennai, if you are living in Mumbai, if you are living in Kerala, on other hand, if you are living in Rajasthan, if you are living in Punjab, if you are living in Haryana, depending on which season you are watching this lecture. Obviously, if you are watching this lecture right now during the monsoon season, there is high amount of water vapor and that is why there is rainfall. But if you are supposed to watch this lecture in December, the amount of water vapor will be less. The air will be dry. Why air will be dry? Because there is no water vapor. What is the practical implication? We use cold cream to make sure our skin is moisturized because there is no water vapor in the atmosphere. The atmosphere is dry. And there is, or if you are living in the coastal regions, for example, Chennai, Tamil Nadu, Chennai, as I said, Kerala, Mumbai, any of the coastal regions, there will be a large amount of humidity in the atmosphere. That is, there is large amount of water vapor in the atmosphere. So this amount of water vapor in the atmosphere, unlike gases, this keeps on varying according to the seasons, according to the area where you are living. As I said, if you are living in Chennai, Kerala or Mumbai, or if you go down near the equator, the amount of water vapor goes on increasing. If you are moving away from the equator, if you are going towards the polar regions, the amount of water vapor will keep on decreasing. So the water vapor depends on the latitudes, the water vapor depends on the seasons. And the small particles, dust particles, ash, many other things which act as salt, pollen grains, this all make up the particulate matter. So the atmosphere is composed of gases, water vapor and the particulate matter. Now first studying the gases in detail. If we study the gases in detail, our atmosphere is made up of more than 78% of the atmosphere is made up of nitrogen. %21% of our atmosphere is made up of oxygen. That means 78% is nitrogen, 21% is oxygen. Can we say 99% of atmosphere is made up of nitrogen and oxygen. 99% of our atmosphere is made up of oxygen and nitrogen. The remaining gases are argon, .93%, carbon dioxide 0.03%. See how less is the carbon dioxide, and still we talk much more about carbon dioxide rather than oxygen. And the maximum gas which is present is nitrogen, and there is no mention in the nitrogen in our daily life. We are concerned with carbon dioxide. Why? because though the carbon dioxide consists of only 0.03% naturally, it is human beings through our economic activities, through our industrialization, we have increased the carbon dioxide percentage by around 25% in the recent past. That is, after industrial revolution, we have pumped carbon dioxide in the atmosphere, resulting into what we call as a phenomena known as, what is the name of the phenomena? Global warming, climate change, because the carbon dioxide acts like a greenhouse gas. That means it allows the sun's radiation to enter the earth, but it does not allow the radiation after entering the earth to escape away from the earth. So it is transparent to incoming solar radiation, it is opaque to outgoing terrestrial radiation. Such kind of a gases which allow the sun's rays to enter the earth. After that, earth gets heated up. Earth also gives radiation, because any heated body will give away the radiation. Earth also gives away the radiation, but such gases which do not allow the earth's radiation to escape the earth is known as greenhouse gases. Carbon dioxide is one of the greenhouse gas, and because industrial revolution, vehicular exhaust, many things release the carbon dioxide, we blame carbon dioxide a lot. Kyoto Protocol is for reduction of a carbon dioxide. Climate change is concerned with mostly with reduction of greenhouse gases, but the main we are talking is carbon dioxide, because we have pumped carbon dioxide more. Though still methane, carbon monoxide are other greenhouse gases also. Water vapor also acts like a greenhouse gas. That is, if there is too much humidity in the atmosphere, pasina kab aata hai? Not when there is a cold climate. You feel sweating, you feel sweaty, you feel humid if there is a hot climate, June, July, August. That is, this is the area when you feel too much humidity, you feel uneasy. If during the April and May season, even the temperature is very high, but still you can sit under the fan or cooler and you will still feel better. But if you put on your cooler, if you put on your fan, if you put on your cooler during the month of June, July and August, the room will become unbearable. Why? Because too much humidity will be there. Too much humidity is not possible, is not conducive for human life, because humid water vapor also acts like a greenhouse gas. So coming to that later on, we'll do it. So composition of the atmosphere. Atmosphere is composed of 7 to 8% nitrogen, 21% oxygen, 0.93% argon, 0.03% carbon dioxide, 0.03% carbon dioxide, 0.02% neon, 0.02% neon, 0.005% helium, 0.005% helium, and after that there is a presence of krypton, xenon and hydrogen. After that there is a presence of krypton, xenon and hydrogen. This is how our atmosphere is made up of. It is made up of different kind of gases. It is also made up of trace elements of krypton, xenon, methane, etc. are the trace elements. Now what you have to remember, you remember these two is they consist of 99%. After that what? Argon, and after that carbon dioxide, and then is the neon. Helium, krypton, xenon are the trace elements. Krypton, xenon, methane, they are so less, you don't remember their percentage. They are trace elements. They are found in the traces or in the very, very low format. So you don't have to remember what is their composition. But remember that the composition of nitrogen, oxygen, sorry, I made a spelling mistake. Oxygen is the main, these are the main elements. Out of that, carbon dioxide is most important. Why it is most important? As I told you, we talk more about carbon dioxide is most important. Why it is most important? Because it acts like a greenhouse gas. Because it is a greenhouse gas. GSG means greenhouse gas. What is a greenhouse gas? Which means it is transparent to incoming solar radiation, while it is opaque to outgoing terrestrial radiation. It's opaque to outgoing terrestrial radiation. What does this mean? This means that if this is the solar, if this is the Earth's surface, and if this is the gaseous envelope, that is the atmosphere which covers the Earth's surface, the carbon dioxide, if this is the gaseous envelope of carbon dioxide will allow the solar radiations to come inside the Earth. The solar radiations will heat up this surface of the Earth, and after heating up the Earth's surface, because of heating, it will give away the terrestrial radiations. After the heating, the Earth will get heated up, and any heated body gives out radiations. If you heat up water and if you take up your hand near the water or near a hot vessel, you will feel the heat from where the heat is coming through. The heat is coming through radiation. So as a result, even the Earth which gets heated up due to sun's energy, it is giving out radiation. Now this radiation is not allowed by the carbon dioxide to escape. It is reflected back. This radiation, it is reflected back. It will be reflected back inside the atmosphere, heating up the lower atmosphere. Such effect is known as an greenhouse effect. So it is transparent, carbon dioxide or any greenhouse gas, it is transparent to incoming solar radiation. Now look at this figure. The incoming solar radiation, if you remember physics, if you remember your school days, any heated body which is having very high heat, it gives away radiations in the form of short waves. While a body which gets heated up, which is having less heat, gives out radiations in the form of long waves. So sun, what is more hot, sun or earth? Obviously sun is more hot, and therefore the solar radiations are in the form of short waves, while the terrestrial radiations are in the form of long waves. So can we say that greenhouse gases are transparent to incoming short wave radiations, solar radiations, short wave radiations? So they are transparent to short wave radiations while they are opaque. That means allowed nahi karte jana bahar. So they are opaque to long wave radiations. So what are the greenhouse gases? because it is a greenhouse gas. What does the greenhouse gas means? Which is transparent to incoming solar radiation, which is a short wave radiation, while it's opaque to outgoing terrestrial radiation, which is a long wave radiation. एक याद रखना, body like sun which is having very high temperature will always emit short wave radiations. Okay, मैं ये insolation में फिर से करूंगा. These are known as greenhouse gases. That's for because it is a, which means it does not allow the terrestrial radiation to escape, resulting into heating up of the lower atmosphere. Therefore, carbon dioxide heats up lower atmosphere. Or we can say any greenhouse gas heats up the lower atmosphere. What are the different greenhouse gases? One is carbon dioxide, the other is methane, one is carbon monoxide. This all are CFCs. That is, these are the different kind of CFCs which we use in deodorants, which we use in refrigerators, chlorofluorocarbons, hydrofluorocarbons. This all act like a greenhouse gas. Water vapor acts like a greenhouse gas. I will give you the list in the attachment for the different greenhouse gases. So, therefore, it heats up the lower atmosphere, resulting into why are we concerned? Economic man. Economic man means industrialized and economic man who engages in economic activity has increased. The proportion of greenhouse gas, especially carbon dioxide, after industrial revolution. Resulting into global warming. Resulting into global warming and change of a climate. Not change of a weather, change of a climate. We never say weather change, we say climate change. Okay, and if you want to go for a picnic, what you see? You see climate of an area or weather of an area? We see what comes in the daily newspaper or what comes in the daily news channel. Climate report or weather report? It comes weather report. When we talk about the long-term perspective, we talk of climate change. The difference between weather and climate. We'll do it in the next part. Okay. So the economic man has increased the proportion of carbon dioxide after the industrial revolution, what we call as in global warming, resulting into we have numerous global warming resulting into climate change. Now, to stop the climate change, what we had? Kyoto Protocol. What did this Kyoto Protocol said? It said limit the level of CO2. Limit the level of CO2. And from when did the level of CO2 start increasing? From the Industrial Revolution. Where did the Industrial Revolution start? In UK, in developed countries. And that is why Kyoto Protocol has given more responsibility, burden on developed or Annex 1 countries. Annex 1 countries, which are, that means developed countries. From where did it start? It all started at a Sustainable Development Summit. or Earth Summit at Rio de Janeiro in Brazil. It is known as a Rio Earth Summit. It is known as Sustainable Development Summit. When did it occur? It occurred in 1992. Did the word sustainable development came in 1992? No, in 1987. I am not going because we are doing it as a separate topic. But CO2 lowering of the Earth atmosphere, it hits up the lower atmosphere. Why? Because of industrial revolution resulted into climate change, and to stop that we had a Kyoto Protocol. Kyoto Protocol said limit the level of CO2. The burden was on or Annex 1 countries, which all started in Sustainable Development Summit. That is why you must have heard the common term shared but differentiated responsibilities. What is the shared responsibility? We all human beings have to limit the carbon dioxide level. We all are responsible. We all have shared but responsibility of limiting the greenhouse gas. But differentiated means who did the first kind of a global warming? It was industrial revolution in the industrialized countries, which are now developed countries. So they have more responsibility as compared to the developing countries like India or underdeveloped countries which are present in Africa. That is why shared but differentiated responsibilities. These developed countries are mentioned in Annex 1 of the Kyoto Protocol, and hence they have to limit the level of carbon dioxide. So this is the carbon dioxide, or this is one about the we were doing of the composition of atmosphere gases, then we went to carbon dioxide, come back to the composition of atmosphere. The second important component of atmosphere is water vapor. What does the water vapor determine? The water vapor determines the amount of humidity in the atmosphere, it determines the amount of humidity. Is the composition of water vapor same or changes? It is variable. Amount of water vapor keeps on changing. As per height, as per seasons, and as per latitudes. So the amount of water vapor is not constant, it changes as per seasons, as per height, and as per latitude. 90% of water vapor, what I said, as per height, 90% of water vapor is found up to height of 5 kilometers. Beyond 5 kilometers, not much water vapor is found. वाटर वेपर जितना आप नीचे हो जमीन के पास उतना ज्यादा वाटर वेपर विल बी अवेलेबल. द मोर यू आर क्लोजर टू द सी लेवल, more amount of water vapor. If you go high above in the atmosphere, the amount of water vapor decreases. इसलिए जितना आप जमीन से दूर जाओगे उतना means the more higher you go up from the sea level, the amount of water vapor will decrease. Water vapor की मात्रा कम होगी. And as I told you, water vapor acts like a greenhouse gas. So maybe क्या hill stations are cooler because water vapor is less? Is this one of the reason? I am leaving it to you. We'll come to that in the further part of the lecture. So the 90% of water vapor is found in the up to a height of 5 kilometers. As you are going up from the sea level, the amount of water vapor decreases. Then how does the season affect the water vapor? The water vapor is present in more amount of moisture during summer seasons. That is, during the summer season, we are right now in the monsoon season. Monsoon, the climate is hot. It is a hot, wet kind of an climate. So there is more amount of water vapor, and इसलिए we get rainfall. So higher amount of moisture during the summer season. And latitudes, the closer you are to the equator, there is a more and more amount of water vapor. As you move away from the equator, the amount of water vapor decreases. इसलिए equator में there is everyday rainfall. Why? Because the climate is same throughout the year. उसमें there is no seasons. If you go to Kerala, if you go to Tamil Nadu, you won't find so much difference in the season as you will see in Delhi or northern part of India. क्योंकि अंडमान निकोबार में जाओगे तो और सिमिलर काइंड ऑफ एन सीजन. व्हाई? बिकॉज यू आर गोइंग नियरर टू द इक्वेटर. सो व्हाई नियरर टू द इक्वेटर? बिकॉज वाटर वेपर इज प्रेजेंट. वाटर वेपर की वजह से देर इज हाई हीट एंड ह्यूमिडिटी थ्रू आउट द ईयर. उसकी वजह से देर इज अ सेम काइंड ऑफ एन टेम्परेचर थ्रू आउट द ईयर. देर इज सेम काइंड ऑफ एन सीजन थ्रू आउट द ईयर. Hot and humid season. Such an area which has same kind of a season throughout the year is known as an equatorial type of a climate. So the latitudes, water vapor content decreases as move away from equator towards the poles. That means at the equator maximum amount of water vapors, tropical kind. And if you are moving away from equator towards the poles, the amount of water vapor decreases. As we move away from the equatorial regions to the polar regions, the amount of water vapor will keep on decreasing. What is the importance of water vapor? As I told you, what is the importance of water vapor? First, it acts like a greenhouse gas. When we say greenhouse gas means it is transparent to incoming short wave solar radiation, and it is opaque to outgoing long wave terrestrial radiations. Acts like a greenhouse gas. Acts like a greenhouse gas. Therefore, when it is acting like a greenhouse gas means therefore it helps in heating It helps in heating the surface of the earth. और सबसे ज्यादा कहां है वाटर वेपर? 90% ऑफ वाटर वेपर इज प्रेजेंट बिलो 5 kilometers surface of the earth and therefore and lower atmosphere. And lower atmosphere. And second importance is responsible. Who is responsible? Water vapor. It is responsible for different kinds of condensation and precipitation. Means it will determine whether there is a cloud formation, whether there is a fog formation, etc. And it is also responsible whether there will be rainfall, snowfall, etc. So it is responsible for different kinds of condensation and precipitation. Water vapor acts like a greenhouse gas. It helps in heating the surface of the earth and lower atmosphere, and it is responsible for different kinds of condensation and precipitation. The third important composition of atmosphere is particulate matter. Particulate matter. Now what are these particulate matters, or we can say dust particles in the atmosphere? Or dust particles in the atmosphere. Now this includes smoke. What does this include? This includes smoke, ash, pollen grains, salts, different kind of salts, meteoritic dust, etc. That is natural also, and some of the man-made also. When truck passes, it gives out large amount of black. You can smoke. It goes out in the atmosphere. Chimneys, fly ash in the coal factories, which is harmful to us. This fly ash comes out, and all these dust particles, the jitna zyada dust particles hai, it is harmful to us. But dust particles are always present in the atmosphere. Or some small a very fine amount of dust जो हमने geomorphology में की, lowest, it is carried out for long distance. So these are the different kind of very small microscopic, hygroscopic particles. Very fine minute particles are dust particles or particulate matter, and it can include pollen grains, it can include smoke, it can include ash. जितना ज़्यादा dust particle उतना ज़्यादा is the problems of us. Now the industrial pollution, it has increased the dust particles. For example, fly ash from the coal factories, or you can say carbon monoxide from the factories, carbon monoxide from carbon dioxide, or we can say different kind of a soot or smoke from the factories. Even the car exhaust, hum smoke because of the car emissions, vehicular emissions. We are increasing even the particulate matter. What is the importance of this particulate matter? Artificial rain क्या होती है? We are spraying salt particles, we are spraying silver iodide inside in the upper atmosphere. So if these dust particles are present in the upper atmosphere, So water vapor, when it goes up and it cools down, water after cooling becomes ice or snow. Water after evaporation it makes into water vapor. So water vapor, when it goes up, it cools at this rate, and around this dust particles it forms small it cools down along this dust particles, or it gets attached to this dust particles. Numerous droplets of water vapor come together to form a small cloud. Millions of cloud come together to form large cloud, and this large cloud then gives rainfall. So what is the importance of this particulate matter or dust particles? They act as hygroscopic nuclei. Hygroscopic nuclei around which water vapor cools and condenses to form clouds. Around which hygroscopic form clouds. What is artificial rainfall? हम artificial rainfall में क्या करते हैं? ऊपर जाके we do not put water, we spray silver iodide or salt particles so that they act as hygroscopic nuclei, and hence जितना भी surrounding इसमें water vapor है, it gets attracted to this silver iodide particles, results into cloud formation, and then we get rainfall. So in artificial rainfall, silver iodide or salt particles are sprayed, which act as hygroscopic nuclei. Around which there is a formation of clouds. Around which there is a formation of an clouds. So this is the composition of the atmosphere. That is, the atmosphere is made up of. We have done the composition, height of the atmosphere, and we have also done the composition of different gases. Now for the exam point of view, for both preliminary and the main examination, if the question comes, what is the structure of the atmosphere, what is the composition of an atmosphere, you should mention these three. That is, the atmosphere is made up of gases, water vapor, dust particles. In the gases, know the composition of top three gases. It should come to your mind: nitrogen 78%, oxygen 21%, argon 0.93%, carbon dioxide 0.03%, then helium, neon, krypton, etc. So if you are writing in some of the facts, at least the top four gases, don't know. If you don't know the composition of or the percentage of the remaining gases other than the top four, it's fine, but know the top four gases by heart and underline it while writing the mains examination. And obviously in the preliminary examination they may ask you to arrange the gases in ascending or descending order, or they may ask you give a simple statement like that, like nitrogen or oxygen consists of 99%, whether this statement is true or false, or the argon is less than 1% or more than 1%, the statement is true or false, or the composition of carbon dioxide in the atmosphere is 4%, whether the statement is true or false. False, it is 0.03%. Okay. So our next topic will be the structure of the atmosphere. Okay. So till that time, thank you. Keep on revising the lecture.